So we considered the testing data in the x-axis and y and the predicted value in the y level. So we have to use plt dot xla bel level, and you just give it y underscore test and same plt dot y level y underscore, and you put plot title plt dot title y test versus y train, and then finally put plt dot show, and it will show basically the scatter plot, so how much they have properly predicted the value. So if it is a perfect prediction, then definitely all the points will be on this 45-degree line, or basically the diagonal line crossing this 0 and this extreme corner. So because there are some deviations, so these points are nothing but the prediction deviation. Next, we are going for, let's say, performance measurement. So hashtag here I'm just deleting this, I'm just adding a text over here. So here I'm just putting check the model performance. So here I will add again code. So we'll calculate first root mean square RMSE. So here I'm just writing calculation of an R square score and RMSE root mean square, or here what we consider, okay, mean square MSE. So MSE. So first we will calculate R square by just writing R2 equal to our score. I'm just naming it as a R2 LR because we are implementing the logistic regression, is equal to R2 underscore score y test comma y train y predict, and then we calculate MSE underscore LR equal to mean underscore square error y underscore test comma y underscore predict. So what is the name? PRD. Pred. Just check once, yes, and if you just hit button and then you just print it, print. Here I'm just writing the coefficient of determination, and then here you're just putting comma and just write R2 square or R2 LR. So it will show you the value of r square. So it is around 46. And similarly, I can also write, so if we just copy this and just write mean square error, squared error, and then you just write MSCLR or MSC. So this will actually show the print the root mean square error. So now here in this model of regression, my coefficient of determination is 0.46. So it indicates the variables I consider, they can only explain 46% variability within the model. Now the next thing I just want to check for the regression coefficient, as we have implemented linear regression, and linear regression is a explainable AI mod. It generates explainable AI, so we can easily find out what are the coefficient values of different parameters or the features, and based on that we can make various comment about the features importance within the code or within the model. So calculate the model coefficient. So in that case, what I will do, model, so you have model name, we gave some name to the model. Let me just check what is the model, BS underscore LR. So you just write display and BS underscore LR dot coefficient, and this will show you, okay, double F, I guess. Oh, 1 minute. BS LR dot coefficient, and this thing you have to just display. So I can put print over here, and let me just, I guess display is not working. Print BS underscore LR dot COEF, and if I put, this is also not working. So I can just take the positions and just tap print coefficients are, then comma, then bs underscore lr dot coef, and if I just hit, just check, still it is not there. So here calculate the coefficients and intercept for the model, and here I can just print bslr bs underscore lr dot coef underscore, and then print bs underscore lr dot coef underscore, and then hit. So it is showing the coefficient. So here intercept CPT. If you just put this, so this is the finally the model for that regression. So these, how we can now explain these values or the coefficient values of the different features. So let's say for my first feature was kind of budget. So budget actually influencing most, that's why it's 1.33, and then but it is positively influencing the collection, box office collection. Whether the next one, the next variable, which is views is actually impacting negatively, which is strange, but the order of the value is very less, that's why there is a less impact. But again, the likes and dislikes, they again also impacting that particular prediction of or a prediction, or there is a kind of a positive impact of other two variables, likes and dislike, on the budget or collection, box office collection. Now with the help of regression, linear regression, we have tried to predict the value. Similarly, in the same code, we can implement our KNN based model. So here let's say these part where actually we are just creating R square and RMSE, these two parts are actually same. Where is the difference? In the case of k-means algorithm or KNN algorithm, you will not get any kind of intercept value or coefficient for decision for the features or input variables. So here I am just creating another text, apply, because here onward I am just trying to implement KNN based regression. Apply KNN based regression to predict the box office collection. So what I have to do, I have to just change this model or from this onward, and I have to add one extra line over here. So what I can do here also as first, okay, just remove this, just come to this particular part, then I'm just adding another line of code. Here I'm just writing call the library for implementing KNN regression. So here I can write from sklearn learn dot neighbors NEIGHBO import k neighbor regression. Now it is very easy in case of Google Colab to code, as it on the go it shows various suggestions. Now maybe here again some spelling mistakes. So KNEIGHBO neighbors REGRESSION regression. So what I can do, I have to just check the spelling. Maybe some spelling mistake happens again. So again I'm just write from sk learn dot NEIGHBORS import KNEIGHBOR REGRESSOR regression. So if I hit button, so now it's the spelling is right of that particular library, and we can go for next part. So here the part is same for training and testing, no need to do that. So this code you can straight away just copy paste. Just you have to just change the name of that particular function. In place of linear regression, you have to just write and because we are generating new model, so in place of LR I'm just writing KNN. Here also I'm just writing KNN. So here also you train the model, so your model is trained. Now after that you have to do the same kind of thing, that you have to just plot the prediction. So here you can also just copy paste the same code, and here what I can do, I first I have to generate some prediction. So for that I will go there, here copy this part. So in place of this, so here I'm just naming it ky underscore pred underscore KNN. So this will put the marker. So and also this is the model name need to be changed, KNN. Then hit. So it generates the prediction. Now again same thing, that you have to just copy paste and modify as per your requirement. So go to this, Control B. So remember we have created a new set of prediction, that is from KNN. So that's why I'm just putting KNN after prediction, and this is again test underscore KNN y test y train. Now okay, here actually I did a mistake, so this is nothing but not a y train, this is test versus prediction, y pred and y test. Okay, so again you just generate this, then this, so it will change the graph, again this, again this, here again retrain it, and here I'm just changing it, the name should be changed, so y test, this is y predict PRED underscore KNN. So what happens? not defined. So basically, okay, this is the spelling, so I have to just change key small KNN. So the name is wrong, so again here also I have to change this, and here also I have to change this. Now it will work. So make sure you are using right variable name while working. So this is the two predictions. Now similar to regression also, I can calculate my two values or the coefficient of determination and MSE. So here also I am just copying the same code. See, so in this case also, okay, so this is LR, no, this is not LR, I need KNN, so in that case this will be KNN, okay, let's go KNN and the packet. Also here also I have to just MSE calculation, I'm just naming it KNN, so small KNN, done. So this name will be changed to LRKNN, MSEKNN. Now if I hit, so why KNN is not defined, so why predict underscore KNN. Okay, now we generated a default model. Now already mentioned that in case of KNN model you have to define the number of neighbors. So in that case you can define within this neighbors n underscore neighbors nei gh bors equal to 3. So let's say again if I am retraining my model, and then the coefficient of determination is 0.12, that is very less. Now let us just increase it. So 4, again retrain the model, again I'm generating it, check, so it is increased to 17. So let's say if I make it to 7, so what happens? Let us just check. So it is increasing to 34. So with the increase of number of neighbors, actually my model is performing pretty much well. And also the same thing can be done with the training testing split. If you just change the training testing split like 80% for the training data and 20% for testing data, then also it may happen that your model is performing in a different way. So this was kind of a demo for your regression with the help of linear regression and also KNN algorithm with different k values. So hope you understood how these two models can be implemented into the Python. And also here also we can do kind of a comparison between two models. See, in case of linear regression, it is already giving better result than our KNN based regressor in terms of, let's say, R square value, as a R square is 0.46 and our latest model, that is with k equal to 7, it is producing somewhere 0.34. So now you can just increase the k value and just try to find out where it is actually giving the highest R square value, and that can be done. And also here we can compare two models with the help of the R square mean square error. So in case of KNN, it is generating only 2993, that is a error or mean squared error. On the other hand, regression is generating around 2458, which is better than KNN model. So as per your requirement, you can generate the model and compare. And in case of Python, you have observed it is very easy to implement such kind of models. Now, in case of Google Colab, no need to install any libraries, as all these basic libraries are pre-installed. But let's say if there is kind of a new library you wants to bring, then you have to use pip install and that particular library name to install inside it. In case of offline install implementation, all these libraries need to be pre-installed, need to be installed first, then only you can go for the coding. Otherwise, you will get several errors while implementing the code. Okay, and next we will implement our classification model. So please stay tuned.